Hello guys, welcome back to Engineers Academy. Do subscribe Engineers Academy if you haven't done it yet. Now we are going to solve this problem from Fundamental of Physics by Resnick Halliday, and the problem says that Harvard Bridge, which connects MIT with its fraternities across the Charles River, has a length of 364.4 smoots plus 1 year. The unit of one Smoot is based on the length of Oliver Reed Smoot Jr., class of 1962, who was carried or dragged length by length across the bridge so that other pledged members of the Lambda Chi Alpha fraternity could mark off with point one Smoot's lengths along the bridge. The marks have been repainted biannually by fraternity pledges since the initial measurement, usually during times of traffic congestion so that the police cannot easily interfere. Presumably the police were originally upset because the Smoot is not an SI based unit, but these days they seem to have accepted the unit. So in figure 1.4 shows three parallel paths measured in Smoots, Willies and Zeldas. So these are three length units, Smoots, Willies and Zeldas, and it said that what is the length of 50 Smoots in Willies and Zelda. So we are given the relationship between Smoots, Willies and Zeldas in terms of this figure, and when we have 0 Smoots, so we have 0 Willies, and similarly when Smoots 212 Smoots equals to 258 Willies and equals to 216 Zeldas. So this problem is basically related to the linear interpolation. So how it is done? So first of all, what I will do is that I will plot this Willies and Zeldas against Smoots, right? So this is the x-axis. So on x-axis we have the Smoots, let's say, and on the y-axis first of all I will plot Willies. So we will plot Willies against the Smoots. So now from this figure, when S is 0, that is Smoots is 0, so W is equal to 0. So we can plot that point on this graph, right? So when Smoots is 0, Willies is also 0. So this is our initial point, right? So let's mark this point 0 0, and now when Smoots is 212, Willies is 258. So this one division on the y-axis is 20 Willies, right? So this is 20, 40, 60, and similarly this is 240. So somewhere here is 260. So when Smoots is 212, Willies is 258. So this is when 212, this is one division is 10 on the x-axis, so this is 200, so this is 210, so 212 is somewhere here, right? So this is 212. So if we draw this vertical line, and similarly if we draw a horizontal line at 258, right, this is 258, so these two lines intersect at a point, right? So the coordinates of this intersection point will be 212 Smoots and 258 Willies, and there is a direct relationship between the Smoots and Willies. So what we can do is that we will join these 2 points. So I will join this final point with that initial point. So this will be the straight line which is going to represent the Willies against the Smoots. And in the problem statement it said that what is the length of 50 Smoots in Willies and Zeldas. So this is 50 Smoots. So if I draw a vertical line from 50, so it will intersect this Willies line at some point here. So we need to find this value. So from the graph we can see that somehow 50 Smoots will be around 60 point something, but let's find that value. So let's say that we do not know that value, let's say, and let me draw a vertical line from 50 smooths, let's say. So it intersects somewhere. So we want to find the Willy's value. So let's say that this at 50 smooths, the Willy value is, let's say, W, right? So since it's a straight line and we can find the slope of this line, right? This red line represents the Willies, so we can find the slope of this line, and we know that the slope is rise divided by run. So the slope between this point and this point, and the slope between this point and this point, that will remain the same. So what are the let me find the slope. So the slope for Willies will be the rise. So now this is the rise. So this rise is basically 258 minus 0. So this is the rise in Willies, right? So I will write 258 minus 0 divided by the run. So what is the run? This is the run. So the run is 212 minus 0. So I will write 212 minus 0. So this is the slope. So the slope between this point and this point, and the slope between this point and this point, they will remain the same, since all these 3 points lie on the same straight line. So we can say that the slope, we can find the slope between this point and this point using the same formula. So we can write that this slope will be the rise, this rise. So this rise will be W minus 0, this rise. So let me write it here. This will be W minus 0 divided by the run. So this is the run, 50 minus 0. So this is 50 minus 0. So now let's simplify this. This is W minus 0 is W divided by 50, and this is equal to 258 minus 0 is 258 divided by 212, and if I multiply both sides of equation by 50, so this will give us the Willy's values when Smoots equals to 50. So let's find this. This is 258 divided by 212 multiplied by 50. So this is 60.8. Approximately this Willy's is equal to 60.8, and which is obvious from our graph as well, that at 50 smooths it will be somewhere around that 60 value. This is 20, 40, 60. So this is 60.8 Willies, right? So 50 smooths, 50 smooths is equal to 60.8 Willies. So and now we have to repeat the same procedure for Zillies as well. So again we have to plot the Zillies against the Smoots. So now let's say that on the y-axis we have Zillies, right? Let's say now I'm going to plot the Zillies as well. So we can plot the Zillies against the Smoots on this same graph as well, right? So now as we can see that when Smoots is 32, the Zillies is 60. So this one division on the x-axis is 10, so 10, 20, 30. So this is 30, so 32 is somewhere here. So if I draw a vertical line at 32, let me draw a dashed line at 32. So let's say this is a vertical line. So at 32, so it is somewhere here, right? So this is 32. So when Smoots is 32, Zillies is 60. So let's erase this. So again let's draw a horizontal line here. So now when Smoots is 32, this is 60, right? So this is that point. So let me write that this is 60. Now this is 60. And similarly, when the Smoots is 212, the Zillies is 216. So where is 216? This is 200 and this is 220. So 216 is somewhere here. So now let's move this green horizontal line to 216. So somewhere here is 216. So now this intersection gives us that 212 and 216 point. So now the coordinates of this particular point is 212 and 216. So now let's join this point and this point. This will give us the straight line for zillies against the smooths. So let's join these 2 points. So I will join this point with this point, and this line will intersect the y-axis at some point, let's say. So now again we need to find the value of zillies when smooths is 50. So this is 50, right? This is 50 smooths. So we have to find this particular value. So let's draw a horizontal line here, and let's draw a vertical line here. So we need to find this particular value, which is between 60 and 80. So now let's say that this point is, let's say zillies. We want to find this z value. So again we have to use that same technique. The slope between this point and this point and this point, that will remain the same. We have 3 points, right? So let me remove this this red plot so that we can easily see this. We have 3 points, right? So this point, and at 32 we have 60. So we have this point, right? So we have these 3 points. Let me mark these points. 1 point is here, 1 point is here, and 1 point is here. So now the coordinates of this particular point is 50 and z is not known. The coordinates of this point is 32 and 60. So now we can say that the slope between these 2 points, and the slope between these 2 points will remain the same. So let's write the equation for the slope again. So this will be slope. So the slope for this will be this z minus this value, which is 60. So z minus 60 is the rise divided by the run. So what is the run? The run is 50 minus 32. So 50 minus 32, and this will be equal to the slope between this point and this point. Now the rise for this point and this point is this 216. So 216 minus 60. So this, if I draw a line like this, so this is our triangle, and this is 216 minus 60. So 216 minus 60 divided by the run. So the run will be 212 minus 32. This will be our run. So this is 212 minus 32. So 212 minus 32. So now let's simplify this. This is z minus 60 and 50 minus 32. This is 18, and this is equal to 216 minus 60. This is 216 minus 60 divided by 212 minus 32. So this gives us 13 divided by 15, and if we multiply both sides of equation by 18, so this will cancel out, and we will have z minus 60 equals to 13 divided by 15 multiplied by 18. So now let's multiply this answer, 13 divided by 15 by 18. So this is 78 divided by 5. So let's this is 13 divided by 15 multiplied by 18. This gives us 15.6. So z minus 60 is equal to 15.6. So now we need to add 60 to both sides of equation. So we will have z equals to 15.6 plus 60. So this answer plus 60. this is 75.6. So Zillies is equal to 75.6 when Smoots is equal to 50. So we can say that 50 Smoots is equal to 75.6 Zillies. So here we can see that when Smoots is 50, this vertical line intersects the Zillies graph somewhere here, and this value is 75.6. So the graph told us earlier that this point is somewhere between 60 and 80, and it is between that 60 and 80. So this particular point is 75.6. So now when we have 50 Smoots, so it is equal to 60.8 Willies, and the 50 Smoots is equal to 75.6 Zillies. So I hope you people would have understood this method, which is known as the linear interpolation between any 2 points. I hope this will help you in your learning. Do subscribe my channel if it helps in your learning, and like this video if you people want me to solve such more problems from Fundamental of Physics by Halliday and Resnick.